All right, welcome to our matrix introduction. So this is an introduction to matrices. Here we will learn what a matrix is, the proper terms to use when referring to a matrix, and how to add, subtract, multiply by a scalar, and multiply matrices. All those things in this one video. So a matrix is a grid of numbers or a set of set in a set order. So they're in order in a certain way, okay? So picture any table or spreadsheet, and what you're seeing, that is a matrix. A matrix is arranged in rows, which go horizontally, in columns, which go vertically. So for example, let's look at this matrix right here. So this is a matrix. It's a set of numbers, okay? It's in this set order of 4 goes first, then 3, then 0, then 2, then 9, 1. That's what I meant by in a certain order. This matrix has 6 elements. It has 2 rows and 3 columns. So rows go horizontally, like I said before, and columns, there's 3 of them, go vertically, okay? So we always say the number of rows first. So there's 2 rows and there's 3 columns. So this is a 2 by 3, okay? Also, we can refer to each entry, right, or each element right here. This is the row 1, column 1 entry, okay? This right here, this is row 2, column 2 entry, all right? This is, I'm using the 1, 1, and 2, 2. I don't like that because it can be like, which way are you going? This is row 2, column 3 entry, okay? All right, the 2 by 3 is called its dimensions, and it is important to know the dimensions and the different entries. Okay, so first let's talk about adding and subtracting. So I'm gonna zoom into this, okay? If I wanted to add these 2 matrices, okay? First off, this is a 2 by 2, and this is also a 2 by 2. The resulting matrix is this 2 by 2. With the following entries, 5, -4, 5, 1. So let's see if we can make an observation of how we got this 5, how we got this -4, how we got this 5, and how we got this 1. Okay, see if you figured it out. Look at this one right here. This is a 3 by 1. This is a 3 by 1. And the resulting matrix is this 3 by 1. See if you can figure out where the 11 came from, the -7 and the -2. All right, hopefully you've noticed that in order to get this 5, you have to add the row 1, column 1 with the row 1, column 1. 4 plus 1 is 5. This one right here, 2 plus -6 is -4, so on and so forth, right? 0 plus 5 is 5, yada, yada, okay? This 3 by 1 minus this 3 by 1, we have to do 9 minus -2, which is the same thing as 9 plus 2, and you get 11, all right? -7 minus 0, and you get -7, so on and so forth, okay? So last one right here, we have a 3 by 2 plus a 2 by 3. And notice it's not possible. Okay, so let's make some conjectures about how matrices are added and subtracted. So first off, they have to have the same dimensions. They must have the same dimensions. And secondly, when you're doing this, you're adding the common entries up to get that entry. So if we want the row 2, column 3 entry in our matrix, then we're going to add row 2 and column 3 of our first matrix plus the row 2, column 3 of our second matrix to get the row 2, column 3 of our answer. Okay. Next, multiplying by a scalar. A scalar is a number in front of the matrix. Okay, so if I wanted 2 times that matrix, I get this matrix. If I wanted -5 times this matrix, I get that matrix, okay? All right, so let's look to see how we do this. If you notice, it's just like using the distributive property to distribute the 2 to every term in that matrix. You distribute the -5 to every term in the matrix. So it's multiply every entry by the scalar. Okay, let's move on to multiplication. Multiplication is a bit harder to see what's going on, but if we look at enough examples, we might be able to identify what's going on here. Okay, so first off, once again, notice first off that these do not have the same dimensions. This matrix and this matrix do not have the same dimensions, yet I am able to multiply them. So first off, they don't have to have the same dimensions to multiply them. So let's see if we can notice a pattern on what does need to be true in order to multiply them. So let's do that first, actually. This is 1 row and 2 columns. This is 2 rows and 3 columns. And the resulting matrix is a 1 row, 3 column. Okay, so look at that and see if there's anything you pick up. But what helps us pick up with examples, what helps us pick up things that we're seeing, right? Patterns is the word I was looking for there. More examples, right? So let's see another one. Okay, this one is a 1 by 3, and this is a 3 by 1, and the resulting is a 1 by 1. Okay, so another one, 2 by 2, 2 by 2. You get a 2 by 2. This one here, 2 by 2 times 2 by 2, you get a 2 by 2. This one right here, 3 by 1 times a 3 by 3, not possible. This one right here, a 3 by 3 times a 3 by 1, you get a 3 by 1. Can we notice the pattern? I can't not write this one here, sorry. Okay, do we notice a pattern here? All right, so first off, in order to multiply them, you should have noticed that the inner dimensions have to match, right? 2, 2, 3, 3, 2, 2, 2, 2. These do not match, so it was not possible. 3, 3, okay? So those 5 you're able to multiply, except for the number 5, I'm not able to. Now, the resulting matrix you should have noticed is the outside dimensions, a 1 by 3, 1 by 3, a 1 by 1, a 1 by 1, 2 by 2, a 2 by 2, 2 by 2, a 2 by 2, 3 by 1, a 3 by 1. And that one doesn't matter because it's not possible, right? All right, so now that we know that, we know, I'm not gonna write those down in words, but we saw what happened, is that the inner dimensions have to match in order to multiply them, and you get the outer dimensions in your resulting matrix. So now we have to figure out how do we get the actual entry, okay? So I need to figure out where does this 30 come from? Try to see if you can figure it out. I will give you a clue. This is your row 1, column 1 entry. All right, so let's see if you were able to come up with it. If I take row 1 from this and column 1 from this, all right, so I'll highlight instead of circle. There we go. Row 1 here and column 1 here, okay? I multiply 3 times 0 plus multiply 5 times 6, I get 30. So yeah, is it easy to see like on your own, like that's where it comes from? No, but is that where it comes from? Yeah, okay. This is my row 1, column 2. So you multiply row 1 times column 2. So row 1 times column 2. 3 times 1 is 3, plus 5 times 0 is 0. 3 plus 0, 3. If I do row 1 times column 3, 3 times 3 plus 5 times 4, 9 plus 20, 29. See that? All right, so that's what's happening on all of these, okay? That's how you get your entries. Another one that I want you to notice if you didn't see here, these two matrix multiplied to give you the second matrix. And if you're like, what did you just say? These two, this matrix and this matrix, match, right? They're the same matrix. So when I'm multiplying any number I want by something and get the same number. So what I mean by that is that what number do I have to multiply 7 by to get 7? The answer is 1, right? And so that means that when I multiply something by 1, I get the same number I started with. And we call that the identity. So if I'm multiplying by this matrix right here and I get the exact same matrix that I started with, this is called the identity matrix, which we'll get more into tomorrow. Okay, but if you multiply by the identity matrix, then you are going to get the same matrix you started with. Okay, so let's go ahead and try some examples here. We're not going to do too many, okay, but it's good stuff. It says, if you multiplied a 3 by 5 times a 5 by 8, what would the resulting matrix be? So first off, you can see that you can multiply them because the inner dimensions match. And we know that we get the outer dimensions. So the resulting matrix would be a 3 by 8. Next one, if you multiplied a 7 by 3 by a 7 by 2, what would the resulting matrix be? So if you look at this, the inner dimensions don't even match, so you can't. This would not be possible. Okay. All right, next it says, is 5 times that matrix the same thing as the matrix 5 times that matrix? And it's not. This is a scalar multiplier. That means multiply everything by 5. And this is a 1 by 1 matrix. All right, 2 different things. Okay. All right, and you cannot multiply these two because this is a 1 by 1 times a 2 by 2, and you can't do it. So this has no solution, right? And the other one does have a solution, just multiply everything by 5. All right, so now we have some practice. There's 6 problems total. If you're feeling pretty confident in what just happened, like understanding how to multiply matrices, then you should pause the video and try these on your own. If you're not feeling that confident, then let me do the first one with you, then pause it and try the rest on your own and check your answers, okay? I'm gonna show you how to do all of them either way just to make sure you get the amount of practice that you need. All right, so first thing I'm gonna do is I'm gonna write the dimensions of all 4 of these, just because if it's asking me to multiply, I wanna first check to see if I'm able to multiply. So this is a 2 by 2. This is a 2 by 3. This is a 3 by 2, and this is a 2 by 2. All right, so the first one says multiply A times D. So I can multiply them because the inner dimensions match, and I'm gonna get the outer dimension. Why am I saying dimensions? Weird. I'm gonna get a 2 by 2. So I'm gonna actually just start with my 1 bracket. I was gonna say I'm gonna leave enough space to make a 2 by 2, but I'm just gonna make my first bracket. All right, to get my row 1, column 1 entry, I'm gonna multiply row 1 times column 1. All right, so I'm gonna do 3 times 1, which is 3. I'm gonna write down these numbers so I don't lose my train of thought. And then I'm gonna multiply 1 times -3, which is -3. So I have 3 plus -3, which is just 0. So this is gonna be my work where I show it, and then down here, it's gonna be my answer, 0, okay? Now, I'm gonna erase that so that I don't get lost in my work here. I want my row 1, column 2. So row 1 times column 2. 3 times 4 is 12, plus 1 times 1, which is 1. So 12 plus 1, 13. All right, on to row 2, column 1. So row 2 times column 1. 5 times 1 is 5, plus -2 times -3 is +6. So I get 11. And then lastly, row 2, column 2. 5 times 4 is 20. -2 times 1 is a -2. So I have plus -2 or just -2. And I get 18. So 0, 13, 11, 18, a 2 by 2 matrix. Voila. If you'd like to pause the video and try the rest on your own, that's great. And then you can fast forward through to see what the answers are. All right, D times A, okay. All right, so let's see if we get the same answer, because A times D, D times A, like I know 3 times 5 is the same thing as 5 times 3. Does it work with matrices? All right, so I know I'm gonna have a 2 by 2 times a 2 by 2 again, so I'm gonna get a 2 by 2. I'm gonna start with D, row from D, column from A. So I have 1 times 3, which is 3, plus 4 times 5, which is 20. So nope, I'm not going to get the same answer, all right? So it is not, we can't do that, right? It's not communicative. You can't do it forward and backwards. It's not going to give you the same answer. All right, next, row 1 times column 2. 4 times 1 is 4, plus 1 times -2 is -2, so I get 2. Wait a minute. Row 1 times column 2, that's 4. No, I already messed up, see? Got to pay attention here. All right, 1 times 1, which is 1, plus 4 times -2, which is -8, which is -7. Got to watch out for your mental math here. All right, I'm at row 2, column 2. Row 2, column 2. -9, and then 1 times 5 is 5. So I got -4. And then I just keep highlighting the same thing over and over again. Row 2 times column 2. All right. -3 times 1 is -3, and 1 times -2 is -2. So I got -5 there. Okay. All right, so I need to do something to show my answers, so I'm going to box them instead of just leaving them there because I want to make sure it's known. There's a lot of matrices themselves kind of look like boxes. All right, I'm going to do A plus C, okay? So in order to add two matrices, they have to have the same dimensions. A is a 2 by 2, C is a 3 by 2, so this is not possible. All right, next is A plus 4 times D. So I need to multiply D by 4, which I could do that in my head, but I'm just going to write it right here. That's 4 multiplied by 4, right? Yeah, 16 multiplied by 4, -12 multiplied by 4, which is 4. So this is 4D. Okay, and then I'm going to add A to it. A is a 2 by 2 also, so this is going to be nice and easy here. So I'm going to get a 2 by 2. All right, so A plus 4D. 3 plus 4 is 7. 1 plus 16 is 17. 5 minus 12 is -7. And -2 plus 4 is 2. All right, B times C. That's a 2 by 3 by a 3 by 2. Yeah? So the inside dimensions match. I know I'm going to get the outside, so this is going to be a 2 by 2. Okay, I'm going to write 2 by 2 here so I don't forget. All right, I'm going to multiply row 1 times column 1. -4 times -1 is 4. 0 times 5 is 0. And 1 times 3 is 3. So that's going to give me 7 for my first entry. Now I'm going to do row 1 times column 2. -4 times 2 is -8. Oops, wrong spot. Is -8. 0. 1 times 3 is 3. So I get -5. All right. Now I'm on to row 2, column 1. 2 times -1 is -2. 6 times 5 is 30. If you kind of move quicker through this, it's better. Plus 9. That is 37. And then my last entry, my row 2, column 2 entry. 2 times 2 is 4. 6 times 1 is 6. 3 times 3 is 9, and I get 19. There's my 2 by 2 answer. Here was, me oh my oh. Here's this answer. I don't really need to box it since it's everything. Not possible. Okay, last one, D squared. So D times D. Okay, D times D. I'm going to move this 4D out of the way. And I'm going to write D next to D so I don't mess this up. 1, 4, -3, 1. So it's a 2 by 2 times a 2 by 2. I'm going to get a 2 by 2. All right, row 1 times, let me erase this. Row 1 times column 1, right here. 1 times 1 is 1. 4 times -3 is -12. So that's going to give me my first entry is -11. Row 1 times column 2. 1 times 4 is 4. 4 times 1 is 4. 4 plus 4 is 8. My one went missing. All right, row 2, row 2, column 1. My -3 went missing also. Gotta be careful there. That could give me a wrong answer. 1 times -3 is -3. 1 times -3 is -3, so I get -6 there. And then lastly, row 2 times column 2 is -12 plus 1, which is -11. -12 plus 1. And there's my matrix. All right, that's it for today. Go ahead and do some practice.